I just wanted to take the time to go through the study guide that I posted today. I posted it without the notes for you to try on your own, and then I posted a PDF with the notes based on what we did in class. For those of you who missed it, I want you to be able to have it. I'm going to go through it really quickly, so listen to it twice if you need. Pause the video and try out the questions on your own, and then come back just to hear the explanations. So question 1 says, which table shows a relation that is not a function? So I circled the third one, and I wrote that it's not a function because the input of 1 has 2 different outputs. If you look at the first table, okay, going back to the first table, you see the input of -1, then 0, then 1, then 2. Each input is only there once, so each input has 1 output. The next table has input of -1, input of -1 again, but they both have the same output, so it's still a function. The third table has 2 of the same input, 1 and 1, with 2 different outputs, so that's why it is not a function. For question 2, which graph represents a function? Okay, so the third one is a function because each input has only 1 output. If you look at the x-axis and you see input of 1 on the x-axis only has 1 point coming from it, 1, 3. Input of 2 only has 1 point, input of 3 only has 1 point, and so on. But the other ones I circled where we have a few points coming from the same x value. Over there, it's not a function. Question 3. Sarah is buying chocolate at a candy store. The price she pays for chocolate is a function of the number of pounds that it weighs. What is an appropriate domain? So I wrote the definitions. You could pause the video and just read that part. And then I wrote that the domain is the number of pounds of chocolate. And it's important that we understand that we're talking about pounds of chocolate and not the number of pieces of chocolate. Because if we're talking about the number of pieces of chocolate, we would count 1, 2, 3, 4, 5, and so on. So we would use integers. But if we're using pounds of chocolate, we're thinking of taking a bunch of pieces of chocolate, putting it on the scale, and the scale spits out a number of how many pounds. It's usually not a whole number amount. So we want to use rational numbers to include those decimals. You could be ordering 3.75 pounds of chocolate, or you could be getting 2.89 pounds of chocolate. So we want to include rational numbers and obviously non-negative because we're not going to buy a negative number of pounds of chocolate. So it was choice D. If f of x equals 2x minus 3, we're on question 4. What is the value of f of 8? So if the 8 is inside the parentheses instead of x, that means the input of this function, the x value of this function is 8. So we take the equation, 2x minus 3, and we rewrite the equation with 8 for x, and then we evaluate it. 2 multiplied by 8 is 16, minus 3 is 13, and 13 is the answer. Question 5. We have f of x equals 2x minus 3. For what value of x does f of x equals 27? So here I didn't give you the number inside the parentheses instead of x. I gave you the output, the number on the other side of the equal sign is 27. So that means I want to know, when does 2x minus 3 equal to 27? So I took my function 2x minus 3 and set it equal to 27 and used inverse operations, and I got x equals 15. Pause the video, try it yourself, and you should get x equals 15. For question 6, we have each of x equals 4x squared. What is the value of each of -5? Here we are given an input. Again, -5 is the input of the function. We put an in for x. So we have 4 times -5 squared. And remember that when -5 squared means -5 times itself. -5 times -5 is positive 25. So we have 4 times 25 is 100. And I just wrote a reminder for you, PEMDAS, right? First you do the exponent, -5 squared, then you do the multiplication, 4 times whatever -5 squared was. Okay, question 7. So here we have a graph, and I see the notes are like a little bit messier. Which input value corresponds to f of x equals 5? So that's an output of 5. F of x equals 5, that's the output is 5. So if you look on the graph, you can't even see my decimals. It should say 9.5 and -1.5. But if you look at 5 on the y-axis and find the points that have 5 as the y value, you see 9.55 and -1.55. So the two inputs that give us an output or a y value or an f of x value of 5 are 9.5 and -1.5. Question 8, what is the value of f of 8? So here we have an input of 8. So you look at 8 on the x-axis and find the point that has an x value of 8, and that is 8, 2. So an input of 8 gives an output of 2. Question 9, which table represents an exponential function? When we are looking for an exponential function, we're looking for a common factor. The second table has a common factor. As we go down the table, looking at the outputs, there is a number that we multiply by. 3 times 2 gets us 6. 6 times 2 gets us the next value, which is 12. 12 times 2 gets us 24. 24 times 2 gets us 48. There is a common factor. It's exponential. Question 10, you have $12 in the bank. Each day you add $23. This scenario represents linear growth. When we have a positive rate of change, a number that we are adding each day, or each time x increases, that's linear growth. Question 11, you have $12 in the bank. Each day you spend $1. That's a rate of change of -1. That's linear decay. Question 12, you have $12 in the bank. Each day your money doubles. Doubling is multiplying by 2. Multiplying, that's a common factor, that's exponential. Multiplying by 2 makes the number get bigger, so it's exponential growth. You have $12 in the bank. Each day you spend half of your money. Here, your money is changing by a factor of 1/2. You are multiplying by 1/2. Multiplying by half is less. If you have 3 and you multiply by a half, you only have 1/2. If you have 100 and you multiply by a half, you are left with 50. It goes down. So this is exponential decay. Question 14. Okay, so you had to write linear growth, linear decay, exponential growth, or exponential decay next to each one. 4x minus 3 is linear growth because 4 is a positive rate of change. 2x plus 7, 2 is a positive rate of change, so that's linear growth. 3 multiplied by 2, you're multiplying by a number that makes it get bigger. 3 times 2 is 6. 6 times 2 is 12. It gets bigger and bigger, so that is exponential growth. 6 times 1/5 is exponential decay. Multiplying is always exponential. And if you're multiplying by 1/5, it's going to get smaller. 6 times 1/5 is going to be 6/5, which is a lot less than 6 wholes.